Hi everyone, today we are going to put together some of the things we've looked at in the last couple of days. So we are going to take a look at our cast rule and our special angles, some things that we want to know and that are going to help us figure out some problems. First thing we want to remember is that we can find our trig ratios using a point on a grid. Using our x and y values, we can find our radius, and we can set up our trig ratios. So if we have a terminal arm on our grid, we know that creating our 90-degree triangle here, we have sides x, y, and radius. And those help us figure out, if we're talking about theta, y over r is sine, x over r is cosine, and tangent is y over x. What we want to take a closer look at is in our quadrants. And remember, when we number our quadrants, we have quadrant 1, 2, 3, and 4. In quadrant 1, we know that we have a positive x value, positive y value. So if we look at our cosine, our sine, and our tangent ratios, sine of theta is going to be y over r. Both are positive values, means we get a positive value for sine. Both x and r are positive, so our cosine is positive. And our x and y are both positive, which means we get a positive tangent ratio. Now, if we look at angles that aren't acute, so not in our first quadrant, it looks a little bit different. So first of all, looking at our obtuse angles between 90 and 180, again, looking at our x values, x's are negative here, y's are positive. So if we think about the sine ratio, y over r, y is a positive, radius is a positive, which means sine is going to be positive. For cosine, we have a negative x value over a positive radius, which means that cosine is going to be negative. Tangent, we have a positive divided by a negative, which gives us a negative. So the only ratio that is positive in the second quadrant is sine. In our third quadrant, or angles between 180 and 270, now both of our values are negative. So for sine, we're going to have a negative divided by a positive. Again, our radius is always positive, so sine is going to be negative. Cosine, negative divided by a positive, ultimately gives us a negative. And tangent is going to be negative divided by a negative, which gives us a positive value for tan. So in the third quadrant, only tan is a positive ratio. And finally, in our fourth quadrant, looking at our x and y values, x is positive, y is negative. So coming up with sine, we're going to have a negative divided by positive, which gives us a negative. Cosine, we're going to have a positive divided by a positive, which gives us a positive. And tangent, we're going to have a negative divided by a positive, which gives us a negative. Well, if we take a look at where sines are, or where ratios are positive, so all are positive in quadrant 1, only sine is positive in quadrant 2, only tan is positive in quadrant 3, and only cosine is positive in quadrant 4. Well, if we take a look at CAST, that's what we call our cast rule. And the cast rule tells us what sign our ratios are going to be for each type of angle. Quadrant 1, 0 to 90, all are positive. Quadrant 2, 90 to 180, only sine is positive, and so forth. Okay, and this is going to help us differentiate in some situations, which we will take a look at. So there are a few things we've already taken a look at. Using a point on a terminal arm to state our ratios, we can figure out radius. We can use our calculator if we're given an angle in degrees or radians to figure out our trig ratio. Well, what we're going to take a look at next is some special angles, where we are going to be able to find exact values of our ratios just knowing how big the angle is, and we're going to need to know some of these to save us some time. So let's take a look at some examples. So example number 1, point -3 and 4 is a point on the terminal arm of angle theta. Okay, so we're going to have -3 and 4 over here. And we're going to draw this to help us visualize what it is, what we have here. So -3 and 4. We want to find sine theta. Well, we know that sine theta is equal to, and if we think about it, we forget, we can think about our right angle. Sine of theta is going to be our y over r. So we need our y value, we need our radius. Well, we need to calculate our radius first of all. So x squared plus y squared equals r squared. X is -3, y is 4, and we're going to calculate our radius. So 9 plus 16 means that we're going to have 25 is r squared. R equals positive or -5, but we know that r is positive. Radius is a measure of a distance, so we know radius is equal to 5. Well, now we know that sine theta is going to be equal to our y value over our radius. And note that that's a positive ratio, which makes sense from our cast rule that it should be in the second quadrant. Example number 2, we are going to find sine 10. Okay, this is the second point. We can just sub this into our calculator. Now, we can just put 10 sine 10. We know that sine of a 10-degree angle is equal to 0.1736. For our second one here, now we're talking about radians. We have to turn the calculator into radian mode. And we can do that. Most of you will have a DRG button, and you can just click that button to go between degrees, radians, and grads. Don't worry about grads. Some of you will have a mode button that you'll be able to switch back and forth between, but you do want to make sure that you can calculate this. When you, and after you've changed your calculator into radian mode, anytime we're using a radian measure of an angle, we can just put it in like we do a sine ratio. We're going to do sine, but here you're going to use your pi button divided by 18 in brackets and equals. And sine ratio of any angle is going to be the same. We notice that 10-degree angle is equal to pi over 18, so we should get the same sine ratio. Measures of sides do not change depending on the angle measurement that we're using. So the ratio of those two sides has to come out to be the same if it is the same angle, whether it's measured in degrees or radians. Now, taking a look at our special angles. So 30, 60, 90, or pi over 6, pi over 3, pi over 2. Notice those are equal relatively. So 30 is equal to pi over 6, 60 is equal to pi over 3, and 90 is equal to pi over 2. Well, taking a look at an angle or a triangle formed when we create a triangle, right angle triangle with our 30 degree, 60 degree, and 90 degree angle. Well, if we think about easiest measurements to use, okay, similar triangles, no matter how big we make the x and y values, we're going to take a look at what happens if we have or create an equal triangle underneath. Okay, so we know that this one is also going to be 30. And because this is 60, this is 60, this is also going to be 60 degrees. And taking a look at our measurements, if we make these both equal to 1, that means this whole side is equal to 2. Well, because we have an equilateral triangle, that means that these both have to be equal to 2 as well. So we know that the radius is 2. We know that our y is 1. Okay, so we're going to work with our triangle in here. So we want to find our radius. So radius is going to be equal to x squared plus y squared. In this case, we know our radius is 2. We don't know our x, but we do know our y. So we're going to have 4 subtract 1 equals x squared, which means x is equal to the root of 3. And that's going to happen, that's our most basic triangle measures for a triangle that has 30, 60, and 90 degree measures. We can multiply all of those by 2, again, similar triangles. 2 root 3, and 4 are going to be another set, but in lowest terms, we can now figure out our sine, cosine, and tan. Now again, keeping in mind that that could be positive or negative 3, which tells us whether it's in quadrant 1 or 4. Again, remember, anytime we have a negative x value, we're going to look at our ratios a little bit differently. But in the first quadrant, most basic special triangle, we know that sine of, so thinking about our 30 degree, sine of a 30 degree angle is going to be 1/2. Cos of a 30 degree angle is going to be root 3 over 2. And tan of a 30 degree angle is going to be 1 over root 3. Okay, if we take a look at our sine, cos, and tan of the 60 degree angle, okay, it's going to be sine is root 3 over 2, cos is 1 over 2, tan is root 3 over 1. The biggest thing we want to remember is that for any special triangle, 30, 60, 90, or pi over 6, pi over 3, and pi over 2, we're going to be able to label it. Remember, smallest side goes with the smallest angle. We have 1, 2, root 3 for 30, 60, 90. 1 has to be the 30, root 3 has to be the 60, and 2 is the hypotenuse. Anytime 30, 60, 90, 1, 2, root 3, and we can label appropriately, find our ratios. For 45, 45, 90, again, first thing we want to think about is on a grid. Just taking a look at why we know these things. So a 45-degree angle, creating our right angle triangle again. We know that 45 and 45 are going to be equal. Using our easiest values, we know these two sides are going to be the same. We're going to use 1 for each of them. Well, to determine our radius, we're going to have 1 squared plus 1 squared. So our radius is going to be equal to the square root of 2. And we know, again, radius is greater than 0. So therefore, radius is equal to root 2. So the sides of a 45, 45, 90 are going to be 1, 1, root 2. And that's automatic. So again, special triangles, 45, 45, 90, or pi over 4, and pi over 2, we can automatically figure out our sine of a 45-degree angle is going to be 1 over root 2. Cos of 45 is 1 over root 2. And tan of a 45 is 1 over 1, which is just equal to 1. Okay, again, biggest thing is to know 1, 1, root 2. Next, when we talk about our 90, 360 in this case, 90, 180, or 270. We know that we can pick points on the axes. So here we're going to have x and 0. Here we're going to have 0 and y. Here we're going to have negative x and 0. Here we're going to have 0 and negative y. Well, again, we can pick the most basic values as our y values, anywhere along this y-axis. So the easiest one to use is 1. So 0 and 1. Well, our radius is also 1. Here, easiest to pick is negative 1. Our radius is still going to be 1. Distance from the center to the point. Here, we're going to have negative 1. And here, most basic value we can put in here is 1. So we can determine sine of, let's say, 90. Sine of 90 is y over r. Well, in this case, we have y is 1, radius is 1, so sine of 90 is 1. If we want to know the tan of 270, we're going to take a look at this one. Tan is y over x. So y in this case is negative 1, x is 0. Well, anything divided by 0 is undefined. So tangent doesn't exist for an angle of 270 degrees. Okay, and we're going to take a look at some examples using those. But basically, we want to just remember graphically for our 90, 180, 270, and 360 that fall on the axes, that's how we can come up with our solutions. Now, number 3, we want to determine the exact value of the cosine of 120. So first thing we're going to do is draw our angle. So we know it's going to go 30 past our 90-degree angle. So our angle of 120 degrees in here, we're going to use our right triangle formed with our x-axis, always with our x-axis. So we are going to have, we got 90 and extra 30 in here, which means our angle here has to be 60. And our angle here is going to be 30. Well, this is one of our special triangles. We know this is 1, 2, root 3. So 1 has to go with the smallest angle, 2 with the biggest angle, and root 3 with the middle angle, because the biggest angle goes with the biggest sides. So now we just know that in the second quadrant, x is negative. And remember that supplementary angles have the same ratios, possibly just different signs, which is why we can use this triangle in the second quadrant to use the supplementary angle. So cos of 120 is equal to our x value, which in this case is -1, over our radius, which is 2. Okay, so we also can use the fact that in this triangle, cos of 60 is equal to, if we're ignoring the fact that this is negative right now, cos of our 60 is 1 over root 3, or sorry, 1 over 2. And cos is negative, so we're using our cast rule in quadrant 2. Therefore, cosine of 120 is -1 over 2. So we can either account for the fact that this is a negative here, or we can find the acute one and then use the negative of that because we have an obtuse angle. So the ratios for supplementary angles have the same value, but different signs depending in what quadrant. Second one, tan of 7 pi over 6. Again, to draw this in standard form, we know that pi gets us around to here. An extra pi over 6 means we're going an extra 30 into the third quadrant. So we have 7 pi over 6. We could also have known that pi over 6 is 30 and go 1, 2, 3, 4, 5, 6, and 7 pi over 6. Okay, so we have, again, a right angle triangle formed with the x-axis, always with the x-axis, and we have a 30-degree angle formed in here. So a 60 in here, and what we want is tan of 7 pi. So again, 1, 2, root 3, labeling our sides in our special triangle. We know that is the reduced or lowest terms ratio every single time. So tan of 7 pi over 6. So first of all, we can use tan of 30 from our measures here, are 1 over root 3. Tan, though, is negative, or sorry, is positive in quadrant 3. Cast rule tells us, again, C-A-S-T, tan is positive. So we know that it has the same tan ratio of 7 pi over 6 is also positive 1 over 3. Sine of 315. Again, drawing first of all in standard form, 90, 180, 270, and we have to go 45 past 270. So our 315-degree angle. And again, we're going to create our special triangle to the x-axis. And because we have 45, 45, we know it's going to be 1, 1, root 2. And sine of 315, so first of all, sine of 45 is going to be 1 over root 2. Sine is negative in quadrant 4. Therefore, sine of 315 degrees is negative 1 over root 2. Tan of 180. So we're going to have 90 to 180. Our terminal arm is on the x-axis. Again, thinking about points, we're going to have negative 1 and 0. So tan of an angle is y over x. So tan of 180 is our 0 over negative 1, which is equal to 0. Sine of pi over 6. So pi over 6 automatically we know is our 30-degree angle. So we're going to draw that in our first quadrant. Again, sorry I drew it a little bit small there, but you get the idea. And we're going to have our 30, 60. So again, 1, 2, root 3. It is in the first quadrant. We know it's an acute angle. We know all of them are positive, and that is the exact angle that we're talking about. So sine of pi over 6 is equal to 1 over 2. Okay, so it will get easier as you practice this. Right now you may have to keep looking, using your cast rule, taking a look at sine is y over r, etc. But the more you practice it, the better you'll get and the easier it will be. Okay, questions to practice? As always, let me know if you have any questions. Take care.